Good afternoon, everybody. Thanks for joining our webinar today. I'm Tanya Soletti. I manage marketing for PDT, and I'm joined today by Steve Gaines, who's one of our senior mechanical engineers, and he's going to walk us through some information about two-shot molding. This will be a short presentation, maybe 15 minutes or so, and then we will open up the line at the end for any questions you may have. You can also type those into the text area of GoTo if you wanted to do that during our webinar. So I'm going to hand this over to Steve, and we'll get started.
Okay, thanks for joining us today. And this isn't a deep dive into anything specific in particular on two-shot. It is a topic. We're going to focus mostly on materials and talk a little bit about design and tooling. For the most part, materials is the one area that has really come a long way in this arena in the last 10 years. The tooling is still pretty much a lot of the same approaches, and so is the molding. Okay, so we talk about materials design and tooling, kind of synonymous as we walk through this thing. Material choices have come a long way and have the largest impact in this area, as we mentioned. In the old days, there was a lot of mechanical bonding with two-shot materials. We got to have some illustrations below here. Delamination was a big issue with two-shot materials, as the second shot wasn't really getting a very good chemical bond. So there was mechanical solutions to increase surface area, add details to kind of keep that second shot on there. But you could always kind of get at a corner and start picking at it, and with some effort, you could start a delamination process. This is more in the area of 10, 20 years ago on a lot of two-shot parts. Automotive had lots of two-shot parts that did not have this issue because they were on a lot of stereos and columns and such. And in these areas, you don't really get a chance to pick at anything. But in the tooling power tool industry, where there's a lot of hands-on, soft touch on grips and such, we did have a lot of delamination issues on those products, and a lot of companies shied away from two-shot at the time until the materials kind of caught up and offered engineers and products much better solutions. So we do have a little illustration, kind of a cartoon sketch on what that mechanical bonding was on the left-hand side, the second shot over the substrate, and in some cases where you really just had to guarantee a bond or mitigate against delamination. We have a right-hand view there. That was more of like a overmold case where you could make the part, and put it in a box, and then put it in the tool and shoot over it. Then you could actually put some undercuts and have a very good mechanical bond. So like I was saying, the material science is really the thing that has come a long way on two-shot, with both, substrates being rigid, and in most cases the substrate being rigid, and then the overmold being a soft touch or a lower diameter material. So polymer guys have been able to come up with, compatibility where you have a chemical affinity layer between the first shot and the second shot, and now it allowed engineers, designers, and toolers not to depend on mechanical bonding. And between these two materials, you get a very good bond layer at the affinity layer. So that was really a big breakthrough from the previous materials where we had things that weren't very good compatibility. So under the heat and pressure of the second shot is when this this chemical affinity layer really is promoted, and you really get that in the two-shot versus an overmold. Overmold, you don't get it as much because the first shot has already been formed or cooled off, and then put in a tool, and then a second shot over it. So you get a much better bonding in the two-shot scenario in this case. Some of the examples that we've seen in two-shot, like military, never considered two-shot back 10, 20 years ago. You never really saw it anywhere. And now you're seeing a lot of it because of the chemical affinity and the bonding improvements that have been made in the recent years. Military market used to have a 810, well, they still do 810E or F mill spec where they had to pass a diesel test, and that was always a big issue with two-shot parts or any type of TPE or TPU being the soft touch over it, as the diesel fuel would actually attack it and then migrate down and delaminate. So they come a long way in that area. Medical market actually has lots of two-shot applications, a lot of disposable two-shot applications, and we'll talk about how that can be an issue here in another slide. And also the consumer market actually has lots of examples, including the tool or the hand tool industry, power tools. But toothbrushes are probably the main area here. There's a new toothbrush every 30 days, and most of them are two-tone, three-tone, and most of them are soft touch executions. So there's a slide that kind of shows some of the compatibility between the rigid substrate, which is what we're calling the first shot, and the second shot, which is soft touch. This is something you really want to try to figure out in the product development phase before you're actually laying down geometry. You kind of want to figure out what your materials are going to be, and you have to really work with the suppliers in this case who make the materials and their experiences, and get them involved on what you're trying to do, what your requirements are, what you're trying to do from an environmental point of view. And these guys have expertise and the materials and the overmolds on what's a very good compatibility. As you can see, ABS here with Monprene. GLS makes a lot of materials that are for second shot and overmold. It's pretty rare to get one material that actually is compatible with an ABS and a nylon, and in case they have this. IXEF is another one that's been used heavily in the last 10 years by Solvay, and we've done a program where we had liquid injection mold silicone over the substrate, and that was very good bonding. And at the same time, we had a TPE and another program that used the same substrate. So again, years ago, this was not the case where you can get second shots that were compatible with more than one chemistry. We also tried a copolyester blend and the TPE that was very good. And then traditionally, PC has been very good with TPE and TPU. So some of the things with two-shot up front from an industrial design point of view is, in the past, we have this illustration cartoon on the top where the tooling people and the molders would like a styling groove around that second shot. That way the tool can come in there and have a hard shut off against the plastic. That styling groove may have been, 20 by 20 thousandths, and it was easier to hide any type of flash opportunity. It's a little bit more difficult to get down in there and to try to delaminate stuff. But typically it has a heavier look, more of an industrial look. And the sketch below is more of a refined look where you don't have a styling groove, where your second shot just comes up flush or tangent to the substrate. It may protrude, it may recess, it may be flush, and then this illustration, it does protrude. Industrial designers really prefer this a lot more, but tooling guys get a little nervous, and molding guys get a little nervous, as you can't really have any flash at that shutoff line. But we're seeing more and more of this in the last 10 years as tooling has become more accurate, and the materials have a tendency to flash a little less than they used to. So these are some things that you want to discuss with your industrial design team before you actually embark on what the geometry is. The other key thing is getting supplier involved early. The earlier the better. Preferably you get them involved as you're designing the part so that you can discuss about how you're going to approach the tooling, how you're going to approach the molding. All these inputs involve industrial design and engineering how to design around that. So everybody's going to benefit from involving the tooling and mold house or supplier up front for the two-shot program. The industrial design guys really want to know their limits on shutoffs, parting lines, and how the appearances will be influenced by these constraints and guidelines. Then the engineers, they need to work out the gating, ejector pins, the first shot substrate, and the second shot. There's a lot going on there that integrates with the design and also how the molding and the tooling will be approached. So engineers need to consider wall thicknesses, side actions, and solutions for internal undercuts. Again, it's just another reason that you really want early supplier involvement. Also, you have to worry about cycle times between the first shot and second shot, as this will have a direct cost on your part and quality. We want to discuss if this is going to be a vertical or a horizontal shuttle. There are both solutions out there. Some companies specialize in one over the other. You just want to be familiar with what they have their setup for and what the reason is. Also, you guys have to consider the machine layout or footprint on the floor if this is a new operation where you're buying dedicated machines for your program. All this depends upon annual quantities. It's also an important thing that it lets the tooling and the molding approach the cost or expense involved relative to the quantities. If the quantities don't justify it, then you probably don't want to do a two-shot. You want to do an overmold, which is less money and a little bit more control on your cost. Also, expected quality on the second shot is a huge issue. There's a lot of TPEs and TPUs that have cosmetic issues, so that's something you want to talk about up front, is what type of quality you expect. Kind of set that expectation up front. And obviously, all the secondary operations as far as ultrasonic welding, painting, appliques, it all goes towards trying to pick a supplier early on and working with them to get the best solution. So some of those lessons learned, this all really kind of culminates into some of the things we've learned over the years, is the thinner the second shot, and considering that second shot being soft touch, the more difficult it is to achieve an acceptable cosmetic. It's very difficult to get these things to not flash on thin substrates to get enough flow where there's no cosmetic ripping at the cavity of the surface. So really you want it, the thicker the better, and today's name of the game is everything is going thinner and trying to get less material and such. So there's a kind of a catch-22 there. If you go too thin, some of the troubles you might run into. So the other thing is, the general rule of thumb is to have a polished surface wherever the second shot is going to be touching. We found in some cases that a soft EDM finish or slight texture does improve the bond, but most people still stick to the general rule of having a polished surface. So once you have a polished surface, you could always go to a textured surface and try out what that bond improvement is. But it's really a case-by-case situation. Also, avoid any bosses or ribs that transition between the substrate and the second boundary. If there's a sink mark there at the substrate, the second shot just follows it, and you get a sink mark in the second shot. So you really want to have a uniform wall thickness with no drastic geometry changes between the two shots. So continuing on lessons learned is you want to research the shrink rates as well. Have something that's fairly close. It doesn't have to be right on the money, but it shouldn't be 10x off, which in some cases they can be. So you want to make sure you're looking at shrink rates that make sense for the two parts. Again, that's another thing you want to work with the material suppliers. So the other thing is two shots and overmold products are more difficult to recycle. We kind of ran into this in Europe, where they're a lot more advanced in recycling plastics than we are. And you don't see two-shot and overmold opportunities as much in Europe because of this. So it's another thing to consider if you're designing something for North America versus North America and Europe. You might be thinking about this a little bit differently. Just something to be aware of. And then be prepared to make a few tooling modifications, especially for the second shot, as flash is real common with soft touch materials. The material really wants to, it flows like water in some cases. It's a lot more difficult to control the flash.
So that concludes the information we have here from Steve. If anybody has any questions, I'd ask you to go ahead and put that in the chat area at this time, and we can answer those. So we'll give you a minute to do that. And while that is happening, I just wanted to mention that this webinar series is ongoing. We plan to do one about once a month, so keep checking PDT.com, our insights page, for what's coming up next. And if you ever would like a certain topic covered by one of our experts, please send that along to the email askpdt, askpdt@pdt.com, and we will certainly try to accommodate that. We don't seem to have any questions yet, so I'll just leave this for about 20 more seconds. And again, if you have questions after the fact, you can also send that to askpdt@pdt.com, and Steve would be happy to answer those individually as well if you'd rather do that, not in the public forum. All right, so we're going to go ahead and conclude our webinar. Thanks for joining, and keep looking on pdt.com for our upcoming webinars. Thanks.
Thank you.